All right, what you're looking at is a sheet that you can pick up online at today's homework page, which is January 31st, 2018. And what I want to do is get some of this scary stuff off the screen, and we'll talk about that a little bit at a time. But this is your actual assignment, and you can read that up here. Basically, you're putting together 1 with 5. Now, 1 is lead nitrate. Now, I'm going to look at a bottle here, and hopefully I can hook this up and we can actually let you see a picture of what's going on in the lab tomorrow. And it doesn't look like it wants to come up. I think I'm going to leave that out. But basically in the lab, you're going to have a tray of chemicals that have 12 different chemicals in them. And in that tray of chemicals, yeah, we're still recording. Good. And those 12 chemicals will all be mixed with each other. And you think, oh my goodness, what a terrible mess that's going to be. Not really. You'll find out about that tomorrow, though. But in reality, we're actually going to mix chemical number 1, which is lead nitrate, with chemical number 2, which is manganese sulfate. And then we're going to mix chemical number 2, which is iron 3 chloride, with number 7, which is calcium hydroxide. What a concept. Okay? So the best thing to do, in my opinion, is to give you a chance to see this homework actually get done. So I'm going to do your first few homework problems for you, and that will help you get a start. So here we go. I'm going to do the first mix. That's going to take us up here with 1 with 5. On your homework paper, I want you to do that to identify what you're doing. 1 with 5. So 1 was the lead nitrate. And this is actually called lead 2 nitrate because it has a 2+ charge. And then we're going to mix that with number 5, which is manganese sulfate. And we're going to put the little underlines on, just like we've done before. Now, this is the part that you haven't done, in this class anyway, in the past. And so I'm going to move this up a little bit so I have more room to write. And there we go. On the other side, what I'm going to do is take lead and put it together. He's the first chemical in the first, he's the first ion in the first chemical that we call lead nitrate. He's going to go with sulfate ion on the other side of the equation. And nitrate is going to go with manganese on the other side. So let's go ahead and write those guys. I'll write the first one, lead, Pb. Instead of with sulfate now, it's going to be, instead of with nitrate, it's going to be with sulfate. Now, since sulfate has a 2+ charge, as you see up here, and your nitrate, or your lead, which is from chemical number 1, has a 2+ charge. It's a 1-to-1 ratio, and so we don't have to put any extra subscripts in. And so that's our first chemical on the other side. The second chemical on the other side is nitrate with manganese. So we always write the positive ion first, and then we put in its what's called the an anion, which is the negative ion, and that's the NO3. Now manganese has a 2+ charge. This guy has the 2+ charge. This guy has a 1- charge. So I have to get 2 of them. So basically you're just putting together ions like we've done in the past. But you're actually writing a complete chemical equation now by mixing the two. So now it's time to balance. I look at the leads on the left side of this equation. The lead, there's one lead on the left, and there's one lead on the right. Nothing to do. Life is good. 2 nitrates here, and 2 nitrates here. Notice I didn't do nitrogen and oxygen. Where I have a polyatomic ion, I balance with the polyatomic ions. Makes life tons easier. Just makes everything nicer. So anyway, I'm good on nitrate. Let's look at manganese. 1, manganese, 1. Sulfate, 1, sulfate, 1. So guess what? When I go to balance this equation, there's nothing to balance, so I put 1s everywhere. Done deal. Sometimes you get lucky like this. All right? It's nice when it happens. Don't think it's going to happen a lot. It will happen, though. So let's go ahead with the second one. And what does that guy look like? We are 2 with 7. So 2 with 7. I'm going to write that here. In the class, how are we doing? Does this make sense? Yes.
Is there supposed to be a plus sign between these two?
Oh, yes, there should be. Thank you, Tom. Yeah, there should be a plus here. Yes. And this area here, this should all be off to the right, but obviously I've run out of screen. Okay, so I put it down below. So that was a great clarifying question. All right, so 2 is iron 3 chloride. So let's put on iron 3 chloride, FeCl. Cl3. We need 3 chlorines with this guy. And then we're mixing that with FeCl3 with, it was 2 with what? Oh, 2 with 7. Yeah. Okay, so calcium hydroxide. CaOH twice. Okay, for the other side of the equation, and let's kind of put a line here so we don't get mixed up as we're looking at this. I'm going to bring the page up a little so we have more room now, because now I can go ahead and finish this off on the other side. So, first chemical on the right, again I want to put iron with hydroxide and chlorine or chloride with calcium on the other side. So, iron, Fe, and OH. Now, iron has a 3+. So, how many hydroxides do I need? 3. Okay, then, thanks to tomorrow, I'm putting the plus in there. Okay, the next one is going to be chlorine with calcium. My blue arrow that's at the top, this guy. Okay, so calcium. Now, how many chlorides should I have with that calcium? Calcium should be written first. The positive ion is always written first. Calcium chloride. How many chlorides? 2. Good. What a lot of students do when they're first learning about this stuff is they carry this subscript over to here. Well, that doesn't work. Sometimes it will, but sometimes it won't. It doesn't work in this case because iron is a 3+, and calcium is a 2+. And you'll see that up above in the chemicals that I showed you. Okay? So 2 pluses have to be balanced by chloride that has a 1 minus, and so we need 2 of the 1 minuses to make that work. Does that make sense? Because your molecules always have to come out to 0. You can't have any charge on your molecules. And calcium started out at 2 plus, and chlorine came in at 1 minus. And now you know what to do, don't you? You crisscross the charges. So this 1 minus is the calcium subscript, and the 2 plus is the chlorine subscript. Yeah? Yeah, crisscross. That's all you needed to see, wasn't it? Okay, now we got a balance. So we're going to take this one at a time. Iron on the left is 1. Iron on the right is 1. So far, so good. I'm home free with that one. 3 chlorines on the left and 2 chlorines on the right. Now, I'm going to use that little trick that I showed you before. I'm going to take my 2 here, and I'm going to use it for the coefficient at the iron, which will be a 2 here. 2 times 3 is 6, and the 3 is for the chlorines. Okay? 2 times 3. Okay? Over here, on this side, oops, I lost him. Let's go back and see if I can retrieve him. There, okay, good. Now, on this side, I'm going to use the subscript from the other chlorine. Okay, I'm going to take this 3, and I'm going to put him right here. And then I've got my chlorines balanced. They're 6 and 6. And then we'll go on to balance the rest of it. All right. So let's finish this guy off now. I've just balanced my chlorines, and now I want to balance the irons. So I'm looking over here, and I'm going to have to make me a real arrow. So I'm going to pause my recording and get an arrow in here. Okay, so I'm looking at I got my iron balanced, and chlorines I'm getting balanced with this 3 and 2 business. Now, iron just got changed, so I'm going to have to need a number here to make this 2 work with this side. So I'll go over here for 2 to make 2 irons. When I made 2 irons over here, I also made 6 hydroxides instead of 3. So if I go back over here, I have 2 hydroxides. And if I put a 3 there, or a 2 there, no, 3. So if I put a 3 here, that will make 6 hydroxides. And it will also make 3 calciums. Oh ho! You see, as happens a lot with this kind of work, when I balance the hydroxides out, I also balance my calciums. Because now I have 3 calciums, which I had over here when I did the 2 and 3 business. I took this 2 over here, and then I took this 3 over here, which messed up my calciums when I balanced my chlorine. So now everything should be working. 2 times 1 iron, 2 times 1 iron is 2 irons. 2 times 3 chlorines is 6. So we've got 2 irons here, and we have 6 chlorines because of this coefficient here. 6 times 2 is 3. And now we have 3 calciums. Now we have 3 calciums, both sides. We have 3 times 2 hydroxides, and we have 2 times 3 hydroxides, and everything is balanced. I'm going to do one more for you, and then you get to do the rest of these tonight on your own. So my third problem is going to be 4 with 10. So I have to label that 4 with 10. All right? And chemical number 4 is hydrochloric acid, HCl. And I'm going to mix that. We're actually going to take a bottle and put a drop on our piece of acetate, and then we're going to put the second one on, 4 with 10. 10 is cobalt chloride. So we're going to, oops, I just messed something up here. I'll put this back where it was. Now we're seeing the right part of the screen. All right. I've got to move that over here. Come on. Get this guy. Get this back. I made a big mistake moving that. So we're doing 4 with 10. And 10 was cobalt chloride. Actually, cobalt 2 chloride. Okay, now on the other side, we're going to mix them again. The first ion goes with the last ion of the other guy. The last ion of the first guy goes with the first ion of the second guy. That's over on the other side of the equation in the products. Okay? So now we do the products. And we're going to have hydrogen. As you saw here, this hydrogen with the chlorine. Only the numbers are different. With cobalt that has a 2+ charge, we need 2 chlorines. But when we put hydrogen with the chlorine, we only have 1 hydrogen with a 1+ and 1 chlorine with a 1-. So that gives us strictly 1-to-1 ratio. All right, we're going to go on, and now we're going to put in our second chemical, which is going to start with cobalt. The positive ion always goes first, and the cobalt is going to go with, oh my, I messed up. There we go. Hydrogen goes with chlorine on the other side. And it also has a 1- charge. So that's going to fit there just fine. And now we do the second dude. And instead of hydrogen, we're going to start with cobalt. And cobalt is going to get the chlorine from the other guy. Okay, have you noticed that in both molecules, the second ion was chloride? And that can be a little bit confusing. But cobalt will go with the other chloride, so what's the difference, huh? And so we wind up with exactly the same thing on both sides. And what that tells you is that there will not be a reaction with this, but we can still balance the equation. It's going to be real easy. It's 1-to-1-to-1. So when you do this guy, when you do this match or cross in your laboratory, you will not see any precipitates. Okay, and that's what you're going to see with most of your reactions, is you will see precipitates. So I hope you find this helpful, and I'll see you tomorrow in lab. I hope you find this is going to do what you need to do, and you can do the rest of it on your own.